Assalamualaikum. We are from Group 1. We want to present about our project Vision System. And this is our member of group. First is Nurul, Atiqah, AMIRA. Second is Muhammad ZULFIQRI. Third is EUGENE. Fourth is DHARWIN. And lastly is Nurul, AMIRUL.
Right, my name is Darwin. I'll be explaining about the introduction. So, this study is based on the core idea of camera calibration. Intrinsic parameters provide the basic properties of the camera, while distortion coefficient record the non-linear distortion that affects images. Calibration process, which often includes the use of obvious geometric pattern and image capture from various perspectives, facilitate the process of parameter estimation. This method depends on mathematical models such as the pinhole camera model to recover intrinsic parameter and the distortion model to minimize lens fall in photographs. In the assignment, we are expected to use the MATLAB software, the program of our choice. To carry out the calibration process, we have to use an 8 by 6 checkboard with 25 mm dimension for each square. We will calculate the intrinsic and distortion coefficient of a webcam and calibrate it using the MATLAB software. That's all from me. Thank you.
Hi, Assalamualaikum. My name is Nurul AMIRUL bin ANUAR. So today I'm going to present about the methodology in this assignment. So the first of all, we need to install and open the MATLAB software. And then the second is add or download Computer Vision Toolbox at App tab. The App tab has at the top, at the right of the software. Okay, next is after you have installed the Camera Vision Toolbox, you can see a camera calibrator like the box in the red box. So you need to click the camera calibrator and then you can upload the 30 photos of chessboard that you have snapped at the image. After you done upload the 30 photo that you snapped, you can see the calibrate button at the top. You can click the calibrate button to calibrate the image. After that, you can see the result, which is you can observe the result of reprojection error at the top right. Okay, next is below the reprojection error, you can see the result of pattern centric and camera centric. The pattern centric you can see at the left and at the right is camera centric. These two is the result that you can find after the calibration camera.
So for this assignment, we use MATLAB to get the result. First of all, we open the MATLAB, then we go to the app, then we choose camera calibrator. We use camera calibrator to estimate camera intrinsic parameter. Then we add image. So for this task, it require minimum 12 image. So we use 13 image that we have captured in different angle. Then we select all picture that we want. We click open and okay. Then we need to wait for analyze the image. And this is our image that we insert then calibrate. So here we see the graph of each image. The y-axis show the mean error in pixel, which is from 0 to 0.6, and the x-axis is image from 1 to 13. At below graph, we get the pattern centric and camera centric. After that, we export camera parameter and choose generate in MATLAB. We click run and save file vision. Then we get output extrinsic parameter, visualization and mean reprojection error per image. So here is transition vector for image and this is rotation vector.
Good morning, Doctor. Now I will present the part of result and discussion to you, Doctor. So, for this assignment, for the data of intrinsics, okay, we will get the result of focal length in pixels and principal point in pixels, and also radical distortion. So for extrinsics, we can see that here there are rotation vectors, and also translation vectors, which is in millimeters. So why there are three values of vectors? Because there's x-axis, y-axis, and z-axis, as in 3D. Yeah, and there are 13 values. 13 sets of values, which stands for, we have 13 pictures for this assignment. Next, we are using MATLAB. Okay, by using these 13 pictures in the system, then after we run the coding, this is the camera centric view. As you can see, there are so many different angles of pictures. There are so many angles to overcome, to solve, okay, in this assignment. Okay, doctor, so this is the graph of mean error in pixels. Okay, as we can see, there are 13 pictures for this assignment. Okay, the first one, the mean error is 0.3, second is 0.13, the third 0.42, the fourth is 0.2, the fifth is 0.43, following by 0.32, 0.27, and we came to the highest at 8 pictures, which is 0.55. Then 0.13, 0.27, 0.28, 0.18, and the last one 0.24. So we have the lowest mean error, which is the second and the ninth picture, lowest mean error. So the reason that causing we have the lowest mean error, which is this picture with the camera in its usual position. So the eighth picture, which is the line is high, so maybe the result of the tilted camera, which increased the average deviation of the image from reality.
Assalamualaikum. My name is Muhammad ZULFIQRI RAZALI, DE2100036. Okay, so for the last of the presentation, I will explain about the conclusion. Alright, so the conclusion for this project, the objective of this project were achieved by capturing image of a calibration pattern, which is the 8 multiply 6 checkerbox with 25mm dimension of each squares. Alright, and the calibration algorithm calculates the camera metric using the extrinsic and intrinsic parameter. The extrinsic parameter represent the location of the camera in 3D scenes, and the intrinsic parameters represent the optical center and focal length of the camera. Okay, so the project's main finding, which is the exact characterization of the camera's internal characteristic and lens distortion correction, is known to be important for ensuring the precision and reliability of computer vision applications. And as we try to complete this project, we discover several experimental limits that could have an impact on the outcome. For example, for first limitation, we have limited calibration pattern variability. Okay, it's possible that a calibration pattern with a single size or design won't accurately represent the variety of circumstances the camera can encounter the real life situation or scenarios. So the improvement is to ensure to reliable parameter estimate, use a